network I could find that I could use without violating some copyright or something was a layered representation of tiers. So here you have three tiers. The presentation tier, which is the client machine right in front of the human, the logic tier, and the data tier. And so now we have a situation in which this machine talks to the machine on tier 2, and the machine on tier 2 talks to the machine on tier 3. The machine on tier 3 never talks directly to the machine on tier 1. So again, just as the layers of a single computer are good because they divide up the complexity and make it approachable, the tiers of a network are good because it allows different machines to specialize. Now clearly in a three-tier network, a simple three-tier network, the machine on tier 1 is a client. The machine on tier 2 is a server to the degree that it serves the client machine. But the machine on tier 2 asks for services, usually database services, which we'll get into later, from the machine on tier 3. So the machine on tier 2 is simultaneously a client and a server. It is a server to tier 1. It is a client to tier 3. Now, networks can be thought of as 3 or 4 kinds. LAN, L-A-N, stands for Local Area Network. These are generally the computers owned by a single company, agency, nonprofit, in the same building, wired together or connected through wireless means, using client-server technologies. The point is that we're limited geographically. I believe to the bounds of a single building. It has something to do with the fact that the building is grounded and so forth, electrically grounded. The next step up from a LAN is a metropolitan area network, which means usually 2, 3 or more LANs interconnected with each other. But the LANs are some distance from each other. And they get metropolitan from the idea that, maybe we have one office on the east side of the city and another office on the west side of a metropolitan area. And our MAN is the means by which those two LANs are interconnected with each other. From the user's perspective, it's as if the machine on the other side of town is as accessible as the machine on the other side of the room. But for technical reasons, you can't stretch a local area network geographically across town, but you can interconnect 2 or more local area networks. And then wide area network, WAN. This is, for example, a situation in which a company or other organization has an office in Atlanta and another in France, Paris, France. Well, this is a wide area network because we're not just talking about going across town now. We're talking about going a substantial way around the globe. And again, the distinction is technical. Metropolitan area networks are generally interconnected using microwave towers, and you need line of sight in order to implement that kind of connection between two lands on a MAN. But there's no way you're going to get a line of sight connectivity between Atlanta and Paris, because the curvature of the Earth is in the way. So there are other ways to achieve the connectivity of a WAN, such as, for example, the use of satellites in combination with microwave technology. The Internet is the ultimate network of networks. And many MANs and WANs are implemented using Internet technologies rather than microwaves. And if you have a LAN that uses Internet technologies, you call it an intranet. It's like an internet within the organization. Here's a representation of the backbone of the Internet, at least over the United States. The Internet, as I said a moment ago, is a huge network of networks. And machines are talking to machines, and data is moving between the machines in ways that I will describe later. Basically, it's kind of like the interstate highway system. If a machine is close to the backbone, then the packets, frames, whatever, that it sends and receives to other machines in other places can jump great distances at high speeds. But if a particular machine is not close to the backbone of the Internet, then the data has to move from router to router to router before it hits the backbone and gets to where it needs to be. Again, like the interstate highway system. If you live in the back country and you want to drive a long way, first you have to drive to get to the interstate highway system. Then you can make good time. And if the place that you're going is, somewhere out in the woods, then you have to get off the interstate highway system and eventually arrive where you want to be. I'll elaborate on this later. Here's another representation of the Internet. And when I see a picture like this, I am struck by the similarity between this and what we know about the human brain, or any brain, but specifically human brains. This kind of pattern is it's a fractal, and it is as if we're creating this huge brain that we call the Internet. This vast numbers of connected devices, just as the neurons in our own brains are connected with each other. So in conclusion, individual computers of various kinds have layers. They are designed to have layers, including hardware, operating system, and applications. Client-server computing is the first step in networked. If two machines talk to each other and have a client-server relationship, you have an incredibly simple network. Many networks are organized in